Greetings everyone. I am S.V.UDAY from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic two-port parameters. A two-port network is a electrical network or device which contains two pair of terminals connected to the external circuits. A two-port network is represented by four external variables: V1 voltage, I1 current at input port, and V2 voltage and I2 current at the output port. There are four different parameters needed to analyze a two-port network. One, Z parameter or impedance parameter, Y parameter or admittance parameter, ABCD parameter or transmission parameter, H parameter or hybrid parameter. Let us now discuss about the Y parameter or admittance parameter. Y parameter of two-port networks is a 2x2 admittance matrix. Since admittance is a ratio of circuit current and voltage, therefore this admittance matrix gives a relationship between the input and output current and voltage of the network. It is also known as short circuit admittance parameter. The Y parameter or a two-port network is defined as matrix is equals to matrix Y into matrix V, where matrix Y is the admittance matrix, I and V are current and voltage matrix respectively. Here we can see in this below, I1, I2 are the currents, Y1, Y11, Y12, Y21, Y22 are the admittance, and V1, V2 are the voltages. From the above matrix form representation of two-port network, it is clear that there are four admittance parameters, that is Y1, Y2, Y21 and Y22. Each of them has a special meaning and significance, which can be later discussed in this post. Calculation of Y parameter. Let us consider a two-port network. Let V1, I1, V2, I2 are the input voltage, input current, output voltage and output current respectively. The relationship between the input and output quantities from the above network is obtained using I1 is equals to Y11 V1 plus Y12 into V2, and I2 is equals to Y21 V1 plus Y22 V2. Assume the output of the two-port network to be short-circuited. Therefore, V2 is equals to 0. Now putting the value of V2 as 0 in the equation 2, we get the value of I1. I1 is equals to Y11 into V1, where or Y11 is equals to I1 by V1. Similarly, putting V2 is equals to 0 in equation 3, we get the value of I2. I2 is equals to Y21 by V1, where Y21 is equals to I2 by V1. Again assuming the input port of the two-port networks to be short-circuited, the input voltage will be 0. That means V1 becomes 0, V1 equals to 0. Now putting V1 equals to 0 in the equation 2, we get I1 is equals to Y12 V2, where Y12 becomes I1 by V2. Now again keeping V1 is equals to 0 in the equation 3, we get I2 is equals to Y22 V2, where Y22 becomes I2 by V2. Thus, there are four Y parameters for a two-port or a four-terminal network. Their values are tabulated as below. Y11 is equals to I1 by V1. Y21 is equals to I2 by V1. Where here the condition is output port of the two-port networks is short-circuited. That means the V2 value becomes 0. And the rest two are Y12 is equals to I1 by V2 and Y22 is equals to I1 by V2. Here the condition is input port of the input port of the is short circuited. Significance of different Y parameters. Since Y11 is a ratio of input current voltage when the port output is short circuited. Therefore, it is known as input driving point admittance. Y22 is a ratio of output current and voltage when input port is short circuited, and therefore it is called output driving point admittance of the network. Y12 is a ratio of input current and output voltage. When input port is short circuited, therefore it is called reverse transverse admittance. Y21 is a ratio of output current and input voltage. When output port is short circuited, therefore it is called forward transfer admittance. Equivalent circuit representation of Y parameter. The equivalent circuit of Y parameter for two-port network can be represented using the equations 2 and 3. In the above circuit, the sources Y1 to V2 and Y21 to 1 V1 are called voltage controlled current sources. Thank you. This is S.V.UDAY signing off.